All right, this is extra problems for Chapter 2, kinematics problems. We worked some of these in class, but let's see, number 43. And by the way, these are from the OpenStax, open source physics book. It says a basketball referee tosses the ball straight up for the starting tip-off. At what velocity must a basketball player leave the ground to rise 1.25 meters in an attempt to get the ball? We had a homework problem similar to this, but let's see, we want to know what is our V naught. So we're looking for V naught, and we know that our final velocity at the top is equal to 0. And we know that that position is equal to 1.25 meters. I know that my acceleration is that due to gravity, that's minus 10 meters per second squared. I don't know the time, nor do I know what V naught is. So I have two unknowns in this situation. I don't know V naught or the time. I know my kinematics equations, y equals V naught t plus 1/2 at squared. Now see, I don't know V naught and I don't know t, so I have two unknowns in that. And then I have V equals V naught plus at. Likewise, two unknowns is that in that equation as well. So what I'm going to do is I'm going to solve this for t, and I'll get t in terms of V naught. V, remember, is 0, so t just works out to be negative V naught over a. And then I can take this, and I can plug it into that first equation for t there and there. So I get y equals V naught times t, which is negative V naught over a, plus 1/2 a, and then t squared, which is negative V naught over a squared. Let me draw a little line here. All right. Now, I can simplify this a little bit. Get negative V naught squared over a plus V naught squared. See, I have an a here and an a squared in the denominator, so that goes to a. 2, the negative goes away because it's squared. So I have 1/2 V naught squared over a. And then if I simplify it further, y is equal to negative V naught squared over 2a. Look, I'm going to make a common denominator here, so I'll multiply both sides there by 2 over 2. So I get 2a negative 2 V naught squared plus V naught squared, that's negative V naught squared. And then I can put in my values here. I have y equal 1.25 meters equals negative V naught squared over 2 times negative 10. And solving this for V naught, I find that V naught is equal to 5 meters per second. That's the end. All right, a dolphin in an aquatic show jumps straight up out of the water at a velocity of 13 meters per second. List the knowns in this problem. Okay, we should always do this for every problem. Jump straight out of the water, has an initial velocity equal to 13 meters per second. We know that the velocity at the top is equal to 0. I'll call this V top. I know that the acceleration is equal to negative 10 meters per second squared. Let's see. I like to list my unknowns as well. I don't know how long it takes him to go up. I don't know how high he goes up, do I? No. All right, so that looks like what we have here. So how high does this body rise above the water? To solve this part, first note the final velocity is a known and identify its value. We've already done that as 0. Then identify the unknown and discuss how you choose the appropriate equations for it. Well, my unknown is y, okay? And the only equation for y is this, V naught t plus 1/2 at squared. But I don't know t for this equation, nor do I know y. So I can find t, saying v equals V naught plus at. That is t equals v minus V naught over a. V is v at the top. V naught is 13 over a, which is negative 10. And this gives me my time, 13 over 10, or 1.3 seconds. So it takes 1.3 seconds to go up to his maximum height. And then I can come back to part A and figure out what y is. So that's, excuse me. So now I can say 13 times 1.3 seconds plus 1/2 -10 1.3 squared. All right, using that time that I've now found, and I find a height that he goes to of 8.5 meters. Pretty tall, almost 30 feet. 8.5 meters. How long is the dolphin in the air? Well, it takes 1.3 seconds to get up to the top, so that means that the total time in the air is twice that, or 2.6 seconds. So that's part C, and this is part B, and part A was just listing all the knowns. All right, by taking the slope of the curve in this figure, verify that the velocity of the jet car is 115 meters per second at t equal 20 seconds. All right, so I want to find the instantaneous velocity at t equal 20 seconds. I'm going to take the slope of a tangent line. We have to estimate this. And then rise over the run. Something like that, maybe. That looks like a nice tangent line. My run is 20 seconds. My rise goes from 0 to, looks like, about 2,500 meters. And then I want to find the slope. Remember, we're just doing an estimate here. So I have 2,500 meters over 20 seconds. Zeros cancel. 250 over 2, that's 125 meters per second. And what's the actual value? Oh, 115. So that's pretty good. So I just want to find estimate what is the instantaneous velocity. Now you can do a similar thing here. Let's see, it tells us that the acceleration should be 5 meters per second squared. It's going to be 5 meters per second squared at all times. Let's just find the slope. See, I have a run from 0 to, I think that's 30. So my run is 30, and then my rise looks like it goes from 20 all the way up to 160, so about 140. So 140 over 30. My slope then equals 140 over 30. That's 14 over 3. That is approximately equal to 5 meters per second squared. All right, so that's it for that one. A steel ball is dropped onto a hard floor from a height of 1.5 meters and rebounds to a height of 1.45 meters. Calculate its velocity just before it strikes the floor. Velocity just after it leaves the floor on the way back up, and then calculate acceleration due to contact with the floor if that contact lasts 8 milliseconds, 800ths of a millisecond. And how much did the ball compress during its collision? Draw a little picture here. So in part A, I have a ball. It's falling a certain distance down to the ground. I know that V0 equals 0. If Y0 equals 0, then Y, which is the final position, is negative 1.45 meters. That's at this point down here at the bottom. I know that A equals negative 10 meters per second squared. And I want to know its velocity at the very bottom. All right. So now I can find the time first. I don't know the time. I know to find the final velocity, I'll need to address this. I'll need to figure out V equals V0 plus AT. But I have two unknowns in that, the time and the velocity. So I can do something over here in parallel. That is that Y equals 1/2 AT squared. Remember, this has a V0 T term, but I just left it out here, one, because I'm running short on space, but also because the V0 is equal to 0. And so if V0 is 0, that whole term goes away. Let me write that equation up here, actually. Y equals V0 T plus 1/2 AT squared. And since V0 was 0, this term goes away. All right, so Y is negative 1.45, 1/2 of negative 10 T squared. Solving that for T squared, I find that T is equal to 0.55 seconds. All right, and now I can find the velocity at the bottom. That's going to be 0. That's my initial speed, times negative 10 meters per second squared. That's my acceleration, times 0.55. So it's negative 5.5 meters per second. That's the velocity when it strikes right here, just before it hits the ground. That's its velocity. Now, in part B, what's it asking? Calculate its velocity just after it leaves the floor on the way back up. Okay, so, oh wait, let's see. I did this incorrectly. I'm sorry. I was misreading it. This should be 1.5. So my y height starts at 1.5. And then this actually does work out to be 0.55 seconds. And then over here, I get still 5.5 meters per second. Sorry about that. Okay, so now it bounces back up and it goes up to 1.45 meters. So in part B, I have this situation. This ball goes up and it goes up to a lesser height of 1.45 meters, a shorter height than it was dropped from, because some of the energy is absorbed by the ball when it strikes the ground. Okay, so I want to know its velocity just as it leaves the floor. When we get into energy, we'll be able to do this in a different way, but we're going to do it just using kinematics. All right, so I don't know what my initial velocity is. I don't know how long it takes to go up. I know that my final velocity is equal to 0, and I know my acceleration is equal to negative 10 meters per second squared. So now I want to know, what do I want to know? Okay, I want to know what is its initial velocity. So I have two equations, y equals v naught t plus 1/2 at squared. And then I also have this v equals v naught plus at. Now let's just take a look at these and see which ones are unknown and which ones are known. I know y. I don't know v naught. That's an unknown. I don't know t. That's an unknown. I know v at the top. I don't know v naught, and I don't know t. So now we have a system of two equations with two unknowns. I'll need to substitute one equation into the other. Almost always when you're doing this, you'll substitute this equation into the left-hand side, just because the math is a little easier when you do that. So what we're going to do, since we're trying to find v naught, we're going to solve this equation for t. Remember, v is 0, so this is equal to negative v naught over a, because this term is 0, v. That's the velocity at the top. And now I'm going to take this term, which is t in terms of v naught, and I'm going to plug it in here, and I'm going to plug it in here. And then I'll have an expression that's all in terms of just v naught. V naught times negative v naught over a plus 1/2 a negative v naught over a squared. And now I need to solve this for v naught. If I follow this and I simplify it, I'm going to leave those steps of algebra to you, but I will find that y is equal to negative v naught squared over 2a. We did a very similar thing earlier. And then if I solve this for v naught, which is the square root of negative 2ay, this comes out to be putting the values in for a, which is negative 10, and y, which was 1.45. I get a value of positive 5.39 meters per second. So that is my initial velocity, which is 5.39. Notice that this is less than the velocity that we found in part A. That is the velocity that it was going downwards with. All right, let's look now at part C. Calculate acceleration during the contact with the floor if that contact lasts 0.08 milliseconds. Okay, so now we're looking at part C. We want to know its acceleration. I know that my time is 8 times 10 to the minus 5 seconds. And I know that my initial velocity is equal to negative 5.5 meters per second. And my final velocity is equal to 5.39 meters per second. So now I can find the acceleration. I say v equals v naught plus at. And a then is equal to v minus v naught over t. Of course, this assumes that we have constant acceleration, which may not be the case in this instance, where this ball is actually compressing when it strikes the floor. But we'll take that as an approximation. And then I can put in my values here. I get 5.39 minus a negative number gives me plus 5.5 divided by my time, which is 0.08 milliseconds, or 8 times 10 to the minus 5 seconds. And I get an acceleration of 136,000 meters per second squared. That's the answer there. That is the acceleration required to make it turn around and go the other direction. And how much did the ball compress during its collision with the floor, assuming that the floor is entirely rigid? Well, what do we know here? We know that our initial velocity is equal to negative 5.5. And we know that our final velocity equals positive 5.39. We know that our acceleration now is 136,000. And what else we know? We know that our time is 0.08 milliseconds. 8 times 10 to the minus 5 seconds. And I want to know the time. Actually, no, I just want to calculate y. This is a little bit of a estimation here. It's actually a slightly more complicated question, but we're just going to go with this. Y is equal to v naught t plus 1/2 at squared. And putting in these values, I find that it's 0.0012 meters